All right. Welcome to the lecture read session 2. May I please confirm that I am audible? Am I from? Thank you very much. Okay, great. So, questions from the previous slides? No questions. So let's continue. So what we have seen in the last thing here also, as I pointed out, that there is a small mistake into the argmax. So we are going to talk about very important condition, that is imperfect real-time decisions. So what happens? You know that what is the difference between DFS and BFS? Okay, what is between DFS and BFS? D versus BFS. DFS and BFS. First, let's ask. That is that. Let's assume that this is the tree. Okay, this is the tree. Let's assume that this is the tree. And most of the time we know that these trees are going to be very large, and therefore they may have infinite number of infinities, because you can keep playing the game and it is not going to end. Let's assume your solution, one of the solution is stored here. Okay. Okay. So what may happen that that from here, in the depth for search, the search goes into the depth. From here it goes here, here, and when it checks that there is no further nodes, you back and go to the second place. As I told you, that it is possible that there could be infinite nodes. So infinite node, it goes and goes on. It would never come back, and it can never give you this particular solution. Problem with the DFS. But in DFS, we know that BFS, the forwards is this, that initially you are here, then you test, then this, then you come back here, then this is not, and you would be able to reach the solution. If we know the solution is going to lie in this particular depth, BFS is going to give the solution, but DFS may not give you the solution. This is a big problem. Okay, and another thing that recently we have seen needs to find out if you what it needs to find out. If you are here, then you have to look all the places where the your opponent what he can take, and you would evaluate that what the opponent can take, and then based on you can find out that what is the best move for me. Usually it requires that all the possible things need to be explored into this line, all the lines, to single move at this particular location. So that's difficult to find out because you don't have this much capacity. This looks like that you are going to be to the trap of DFS. You may get the solution at all. And so, even if you have the capacity, so therefore it is going to take a lot of time. And playing game of chess, you want to have the limit time, because your opponent should give you next move in the set 6 minutes. So you give a lot of time. Rest of all these things, it is a good idea to reach somewhere. And I can tell that I would not evaluate it whenever I went to this place. I would not evaluate after the depth D. Okay. For this particular depth D should be constant, and what should be done. This is what the subject matter we are going to discuss now. Okay. The point is that whenever you are going to do these kind of things at this position, because you should give some value, okay, because you know the actual value, because actual values are into the game of, let's assume, game of chess. Actual values are +1 for win, 0 for lose, half for draw. So, but these things now, since they are not final state, they have some other values. These values, they somehow represent that what is the probability of your success if you are taking this particular move. What is it? So how to find out these value? We don't know. So let's call it EVAL. Evaluate at this particular state. EVAL at a particular state tells you what is the, it is give you some relationship that how good we are going to be. So this is we are going to talk that generating the entire search space is overkill and covering till the large depth is not possible. I is to cut off the search tree at some place. What is the place? Cutoff test. It tells that if you are into the state S and you have reached this particular D distance, so there you would not go ahead. You would stop and you would return the eval of that particular state. So one thing I just wanted to add over here is sometimes all the things may not be at the same level. Okay, sometimes you are going till this particular place and this is not the stopping place. That also be possible. Okay, so you want to see this particular function there where you change this particular minimum with the minimum, that is some kind of heuristic. Using heuristic you want to apply the cutoff test and then you would stop at that particular moment. So when you go down, you increase the value of D with a D plus 1 so that you find out some sense that whether you should stop or go ahead. So this algorithm is important. So you understand this? In the interest of the real time being real time, this is needed that instead of using the actual values, you start at some particular point. I told you why. Because in the DS mode, if you go ahead, you may be stuck into the place where you would not be able to find out any solution. So therefore, it is better to be quick that you stop at some particular moment. So now it is important to know that what should be the property of this particular function. So evaluation function, what should be the property? We are going to discuss about the properties of the evaluation function. So we discussed that it returns the estimate of the expected utility, means what is expected thing, that if you go ahead by this, what is expected value. Okay. If you change this particular value to the another value, your performance would differ. So somehow you can give me the best value, and what should be the best value is actual value. Somehow you give me the actual value, your performance will be actual. Give me some bad value that some bad places you are going to take the move, and right places you are going to take the things. So only it is going to harm you because it's not going to help you anyway. Because if all the actual values were available, then you have taken the best way. So eval function is given to you. It is not what bad it can happen. It can have that your performance can go wrong. Your performance cannot improve. Okay, but you know that this particular property this should be there. Okay, what is the probability? What is this property that if you are into the win scenario, because there is some state which are the winning state, somehow reach to that particular state, then the eval function should, whatever value it gives, should be greater than the lose value. And come in between, means if you get the draw at some states, that particular state have the eval value should be greater than the lose value. The draw should be having less value than the win, because winning is more important. Also, this is also important point that since we are going to be real time, and in the interest of time only we are going to do all these things, therefore computation should be quick. Okay, these things computation should be quick. Value should be related to the actual chance of winning. It should be related to the actual winning of the eval. Okay. How to make these things? So is that you can use the number of pawns, number of queens, such as how many number of pawns there for white, how many number of pawns are there for the black, how many queens are there for the black, how many queens are there for the white, and simply all other things you can use those things as a feature, and design a function that given these values it can tell you that this is what you are going to as your expected value to be there. Okay. Sometimes you since only see the board positions sometimes means just counting that how many things are there may not be so appropriate. Sometimes you want to find out the what is the strategy, because sometimes if you're, even if you are having less number of things, you are more stronger. As if you have a queen and at the end you have the queen, and other your opponent does not have the queen, so definitely you have a better chance of winning, because space the queen has to move, and for it would be more lethal. If yes, initial state of the game you have the queen, but queen is not active because the places are blocked. But final stages you see that less number of things there on the board. Therefore, the queen has a more chance to more space to move around, and therefore it would be more lethal for the opponent. So there could be, you can see that what are the various categories of the things are there, such as what are the various categories of games that are possible. Sometimes pawn versus pawn versus one pawn, or suppose that there is some experience that suggests that the if you are into this kind of scenario, you initially detected that you are into this particular category. There could be this category of the game, and until that if I'm into this category, 72% of the chances that I'm going to win. With a 72% of chances I'm going to win, and 20% chance I'm going to lose, and 8% of chance I'm going to draw this game. Somebody if gives you this information that you are into this category of the state, and therefore if you are into this category the state, then 72% is the chance of your winning, and 20% of your loss, and 8% is the draw. The evaluation function could be this kind of 72 multiplied by 1, because when you get when you win, and 0.2 multiplied by 0, because when you lose you don't get anything. 0.08 into 0.5, because you get 0.5 when you have the draw. Similarly, you can find out this value. The way to find out this particular eval function could be this, that you utilize this thing. But it is better because this is one way, so you can find out others also. At some place you can see that there could be multiple things are applied, such as you can apply, you can also use features, you can also use a strategy. As strategies, you can see that at this particular various strategies are possible. Using all those things, you can construct a weighted function out of this. That first one could be that how using feature, how many pawns you have, so based on that you can come up with this feature. Second thing, third thing, and you can find out some linear combination of these things to come up the eval function. So it's difficult to directly tell that what should be the function, but it depends on the game, it depends upon the statics, and now a lot of inner information, means knowledge is also needed to frame these kind of scenarios. But you have seen that how we can one way to how we can construct these evaluation functions. Correct? And there are some important considerations, such as cutting up the search. As when you should cut up the search, means when you are going down. I told you that when I'm going down here, at what point I should cut this particular place. Should it be other places should be same, or sometimes you go down and you sometimes you go to improve. So there is a very important concept that is called the quiescent state. Okay, what is the quiescent state? So just zoom into the game of chess. Sometimes you are into the scenario when the opponent is going to give you very big problems. Sometimes you are into this state, and sometimes you are into this state that no big problems are not there. He can only do small kind of problems. Okay, having fixed may not be a good idea. Therefore, states that are unlikely to have wild swing. What is a wild swing? Sometimes he can give me that suddenly I become very advantageous, or suddenly I becomes very advantageous. There could be some board positions where, for example, your king is on the attack, and now you have to take decision whether you would lose some other pawn thing, some other things, or what you have to do. So those things are actually difficult states. Okay. Some states which has very less chance of moving, so that those kind of states are called quiescent states. And for the idea is that if you are here, you go down until you reach to the quiescent state, and they don't go below. but going down, you find out something that can be a big thing. Then you go down until you find out a quiescent state, and then you don't expand after this particular thing. It is a yeah. Understand? In the game of chess, you see that there are some board positions where there is a big thing going to happen. In between, there will be some where big things are not happening. So simply, you can do some small changes. So you want to reach to until that particular place where big things are not happening, and after that thing, you stop growing the tree. It would be a horizon effect also sometime, and this is also very difficult to eliminate. What is horizon state? That there would be a state that where you see that there is a big problem because somebody is attacking on me, and now cannot take. He is going to kill one of my something. So what you can do that sometime, although you cannot immediately save your thing, but you can take your time, because what you can do, you can roam around, you can take your time, you can either ka sam kuch chal diya. So what is going to happen that he cannot take that move right now. He would take some more time he would be able to take this particular thing. So this is called the horizon effect, where ultimately he would be able to kill that particular thing, but initially between he can take the he is diverted. Immediately he cannot take the thing. So it's possible that sometime there is a possibility that since he is going to take another move, he's going on to the lethal moves. So it may happen that in between his mood changes and something could happen. Okay. These kind of things can also happen, because then he would be changing the state, and then in between what you can do, because he had done some other move and he is not taking this move, so it may be possible that you may reach to other state that you have encountered earlier. हो सकता है ना कि because you are not going to this particular move, but since you have engaged him into another kind of moves, we have gone to because of some movement, reached to some state that was earlier, and now you have a chance to go for the good move that you have not taken earlier. It may also be possible. So I take a previous good move. This is called the singular extension. That although you are into the difficult scenario, but you have taken time by giving some different kind of moves, and now you have reached to another position from where you can take the singular extension. Means you can take the previous good move and you can continue. These things can also be possible to expand like that. What is sometimes you can also do the forward pruning, and this is an important concept. Most of the time when you are playing the game of chess, what you do, that there are various possibilities there, but you don't consider all of them. You only consider few of them, because those things are good. You think that if I can go into this direction, that would be fine. So out of 100 choices, you are only a player, as a human player, only you are considering 5-6 moves that are for you, and you are evaluating those things, that what is going to happen at the end. So this is called the beam search, because now you have a clear ending beam that this is the line on which I am going to play the game, and all the possibilities you are only considering those things. So this is called the beam search. So, but this may be fatal. This may be a very big problem, because you are not considering all the things. Then you would be having a big problem. But again, a way somebody tells you that you don't consider all these things, only consider these 10% or 20% of the moves, use particular idea, then you can also use this forward pruning. So this is the forward pruning. You understand what is the forward pruning? There I say various possibilities available. All possibilities, you are only considering some. How? There is previous knowledge available to you, and you are going in that particular direction. Therefore, I am telling that you are doing beam search. You are doing all the places. You have beam in direction only you are going to. So this is also a one way of pruning. It may be fatal. This may not be a good thing always. Okay. I think that is very important. That is very important thing. Today, I think we are making you expert of the important thing, the search versus lookup. What happens that there are some very good books written about that how to play about the chess. So if you read those books, they would be telling that how to start the game. There could be some very good moves to start. So I would be telling that these are the initial 5-6 moves that are going to be good. So you just record those things, because at the time when you start the game, it's very difficult to find out the actual thing, because now the branching factor is a maximum, because a lot of things are possible. So what you do initially, that use the book to use those kind of moves. Initially, you are not going to apply anything to find out that which is the best move. Using that particular book, that particular thing, that particular policy that is described somewhere as a good move, you are using that to start the thing. And similarly, this may also be possible that at the time of finishing, mean the things are going to end the game. At that time also there were some strategies that if these things are available, then how to get with the strategy so that you can kill the opponent. So at the start of the game and at the end of the game, you can use kind of earlier tested policies to finish the game. Okay, and then you can switch based on that. That will make your game very fast. You can utilize them as a lookup, and for don't search for the initial and end thing, it's an ending thing. You just go for the tail lookup, and that's it for you. So solve for the particular chapter, and the next chapter is the constant satisfaction. Constant. I suggest you that you go and read the chapter 5 fully, because it's a very good chapter, and you can very easily read this. And you enjoy just like a novel, just read this. Most of the things are, for example, whatever I am telling, they are interesting. You just read and you would be happy reading these things. Okay, so next chapter 6 is about the constant satisfaction. That is a very important part. So we from the last chapter itself, we started to the place where we are not focusing on the way that in which we are going to find out the solution. Sometimes we just want the solution, that gives solution. What is the right solution? We don't care about what is the thing which heroes to the solution. So this is something more difficult scenario where a lot of conditions is given to you, and I am asking you that give me the assignment of the variable so that I can get a solution. Okay. Constant satisfaction problem, CSP has a 3 component, initially 3 component. What are those components? Set of variables. We want to find out the values from them. Assume that n number of variables we have. And then D is a set of domains where for every value I tell that this can take the value from the D1. D1 said X2 can take the value from D2, X3 can take the value from D3, Xn can take the value from Dn. These are values are possible. Then I tell you that C is a set of constants that specify the allowable combination of the values. Means these are the values possible, and give a value so that all these constants are satisfied. And what is the value? Can you example? Can you give me an example for this? Can you give me the example? Okay, it should not be clear. Sorry, it should not be difficult. So let me just try to construct an example. You please me. Okay, I need to find x. X means okay. X is x. How many x we have? Let's assume that I have x1, x2, and x3. 3 variables I have. Let's assume. Then what is D? D represents the domain. I can say that x1 can take the value 1, 2, 3. X2 can take the value say 5, 8, 9, 11. And we can take the value 2, 3, 4, 5, 8. Let's assume this. And D, you understand D. These are the D. This is D1, this is D2, and this is D3. Okay, these are the 3 Ds that I have. Okay, now I have to define what are the constants, and I'm just writing. It may not be possible to get the solution. Constant could be this thing. Let's say that is not equal to x3. This is the one constant. Okay, to specify the constant, say that x2 and x3 are participating in this thing. X2 is not equal to x3. So give me an assignment. Okay. See, I want the assignment for x1, x2, and x3. There could be this assignment. So you can tell that I would take the x2 as a 5 and x3 is as a 8, and I can take any value for this. Okay. Then I say, then add another thing, x1 and x3, and I say x1 square. If x1 square is that is okay, so I can give this constant. Now take this one over here. No, and it should be some x3. X1 square should be greater than this. So if I take I8, I think I'm gonna take 8. I have to take different values. So you understand that now the problem is becoming difficult. So more constants are specified to you. So more constant can be specified so that your life becomes very difficult to find out the solution. So you stand with me that what is this scenario? A lot of constants are given to you, and lots of variable, and for each variable what are the possible values is given to you to satisfy all the constants. As I told you that di contains means di, this particular domain contains all the values, and we have seen that what are the values for xi. And then n not to be there, it could be different because di it does not be n, maybe different value can also be possible. Then we not be same thing, okay? Ci, so should I write? Di and n, okay. Each Ci contains pair that I told you just now, that contains pair scope and region. Scope is what are the variable involved. So it tells that x1 and x3 are involved. As I told you, the x1 is not equal to x3. This could also be a condition. To CSP, it needs state space. What is the space? All possible values, all possible combination, state space, and the notion of solution. So if you go here and try to see that what is the state space, what is the size of a state space. So you help me to find out what is the state space over here. So this means all the possible states. How many states are possible? I think solve this problem. This is not a big thing. Please help me to find out how many state space is possible. And because I would be specifying 3 values, now x1, x2, and x3. For how many values are there? 3 values are possible. For the x2, how many values are there? 4 values. For 3, how many values are possible? Values. All how many values are possible? So you find out the multiplication of all these things. 3 values. State space has 60 different values. Okay, and then you can. Is there anything that you move from this state to another state? Good. Okay. Assignment of variables such as this that does not violate any constant is called the consistent. Means it's a good thing. We want to find out an assignment that that is consistent or least solution. Okay. So consistent. So I think I should tell you this, that what is the constant solution? Okay. Constant solution is this, that does not violate all the things, because if specify that these are the constants, I say that for these constant x1 is equal to 2 and x3 is equal to 5. So is a consistent. This particular assignment is not going to violate, let's assume it's going to violate any of the condition. But is solution? Why? Because you have not assigned the value to x2. The point I want to bring your thing, that sometime you find out that this is assignment, that's fine, is a constant or legal solution. But this cannot be a solution, because we want our is to have complete assignment. The consistent means for all variable we want to find out the assignment. Sorry. Is that you want to find out the assignment for the items. So this is clear to you there is some variable that is defined. You can take the values from the domain. There is some constant available. Constant is specified using something. You want to find out what is the state space and want to find out the consistent solutions. But this consistent solution, you want to find out the complete assignment for all the variables. You want to find out solution. For example, assume that you are given three colors, red, green, and blue, and you color following map. This map, what? This is Australia, Australia, and so we gone to the Australia. I think he be knowing these things. I have never been there. Queensland, South Wales, Victoria, South Australia, and Tanzania. So these are the places into Australia. Okay, you color them. What is the meaning of color them? You want to put a color over here, green color over there, red color over here. Okay, this is what I want to do. Okay, can I color him? Color. Yes. So let me get color. I could put red color over here. I could put red color over here. Okay. Then I can also put the red color over here. Is it coloring? Bad color. So here should be some other. Let's blue. So if I put blue over here, color I can put blue also. Okay. And similarly, I can take the green. If I put the green here, how should I can put the green over here? Wait for me. I cannot do this. Okay, I think I can put green over here. What else I do? Any color I can do over here. Red. What I do, put over here. There you go. So look, this is seemingly easy problem. It's not that easy. Okay, for me it becomes very difficult for me to solve. Let me define the problem. The problem is X. X specifies that W, A, N, T, Q, N, S, W, V, S, A, T. These are the places. What are the constant? Constant is this. S is not equal to W, A. So A is not equal to, sorry, S not equal to W, A. They should not have the same color. S A is not equal to N, T. Not be the same color. S is not equal to Q. They not have the same color. SA is not equal to SW. This should not be the same color. SA is not equal to V. This should not be the same color. Okay. Not equal to NT. WA not equal to NT. This should not be the same color. NT not equal to Q. NT not equal to. This should not be the same color. Q not equal to NSW. And NW not equal to V. They should not be the same color. So this is what the constant is. I think you understand this. There are many solutions to the problem. I don't know. It is helpful to visualize as constant graph because you this thing you can present is better if you represent this as a constant graph. And here, if what is this? That all the variables are there. Okay, you put S's between them. If you find out that there is a constant, if there is constant, you put. If they are not, for example, the constant are here found based on the vicinity. So you see that whether there is a road or not, but it is not like that. If the constants are given, you just put in them if the constant is there. So see that there is some places there is a constant. So this is the constant graph. You understand what is the constant graph? You give this thing, I ask you that what is the constant graph you can plot. Okay. Can I write yes? Yes. No. Nobody's no. I ask a very simple question that given this thing, given this graph, can you give us constant graph? It is not. Can you write yes? So how you created it? For a place there is a node. Because there is a node, these are variables for every variable because we want to assign them a color. For every variable, I am going to create this node, and if there is a link, means that there is a constant related. W is not equal to V, so NSW and V have a line. Why the line between NT and SA? Because there is a SA is not equal to NT, there is a constant. If there is a constant, then there is a line. So this particular graph. So can you create this graph? My question is yes. Thank you very much. Not difficult. That's very easy. That's straightforward. But if you write like this, then you step one step forward to a solution. So how to find out the solution for this? Okay. So the one way is to use the constraint propagation. What is constraint propagation? Propagation. What the constraint? Constraint that these are the constraints. Okay, these are the constraints given to you. So initially you put, let's assume that you put SA is equal to blue. Then once you choose this thing, what is going to happen? You can conclude that none of its 5 members could take the color blue. Now you have put the blue at SA, they cannot take blue color. What color they can take? Any other? Taking advantage of the constant propagation, search need to consider only 3 to the power 5 because it was possible. You how many 1, 2, 3, 4, 5 these constants were there. For these constant places, how many colors is possible? 3 colors is possible. You can for this place 3 possibilities were there: red, green, blue, red, green, blue, red, green, blue, red, green, blue, RGB, RGB. So how many total number of possibilities are there to have this? 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3. These many possibilities were there because you can apply any color to them. Assignment for the 5 neighbors. This was the thing. But when you use the constant propagation, you say that no, and these places now. Here earlier you were telling that the possibility is R. You can put R. You can put R. You can put R. D. You can put G. You can put green color. You can green. You can put green color. Blue color, blue color, blue color, blue color, blue color. Next to find out what we can do, you have seen 3 to the power 5 possibilities were there. But you go for the constant propagation, you say that I have chosen the blue over here. No, there is no possibility for this particular blue. This is not possible. So immediately what happens? That 3 becomes 2. Now the total of which are possible is 2 to the power 5. And see that this is a dramatic reduction to the number of states. Now it becomes very quick that very quickly you can find out the solution. Now only you have 32 states and you had 243 states. Just think that this is the way that is the constant propagation. In the constant propagation, you use these values to tell that no, I'm using this constant, and this constant is actually again going to be implemented on these things. So therefore, they cannot take these colors. Now this reduction, and it is 87% of the reduction. You see that how good this is. Now we are going to see one more example, and in this example, crypto-arithmetic puzzle. This is a crypto-arithmetic puzzle. And following addition. So it asks you to find out this kind of thing, that 2 plus 2 is equal to 4. Can you find out that what is the 2 plus 2 is equal to 4? 2 is 4, you know now. So my question is, can you solve this? What is this? These are the digits, na? You ultimately these are the digits. So you, if I want, can you give me some digits? What are the digits? What are the digits? Okay, fine. Okay, digits. I want a digit for these things. Nah, I want a digit for T. T is a W is a digit, O digit, F is a digit, U digit, and R is a digit. Let I put T is equal to 5, O is equal to 2, 3 is equal to 3, F is equal to 5, U is equal to 9, R is equal to 0. I put these things. No, I put this because 5 and 5 T and F become same. They cannot be same. I need all of them to be different. So I put 1 for Zoom because 1 is not I have given to anybody. So I would give 1 to him. This is okay. If I put assignment, what is going to happen? At the it is 5. So I say 5 upon 5. That is 2. 2 by 2. At the O it is 3 by 3. At it is 0. 0. At U it is 9. At O is it is 3. At 1. Is calculation? Can you tell me? Is it calculation? No, wrong. Is my target that I change this thing. Let's assume I say that 5 instead of 5 I put 3. It is 2. It is 1. Many time I'm writing 2. It is 8. It is 9. And here I'm going to get 7. Here I'm going to 5. It might change. You know that what will be this equation. Okay, will that be the right thing? I know. Then find out what are the assignment. So can you give the assignment 1? Can you give such assignment? I want to give you. Please. Can you try the value of T4WO? What is it? Can anybody try? Okay, we find out the solution. Right. So to write out the solution, initially each letter represents a different digit. This is one thing, and therefore you specify that all diff F2WRO. You specify this that all the things are. As I'm writing yes, so I think it is earlier. I need to find out the solution. Okay. Clearly, these are the constant. One constant is the all diff constant that tells that all the values are different. So this is a constant, and these are the values F, T, U, R, O, and this constant is given to all of them, telling that all these things should be different. Additional constants are there. There are additional constants. What are they? O plus O is equal to R plus 10 is C10. This would happen now because O plus O is equal to R. How coming to it may be possible that since you know that these things are not very simple, there will be something hidden also. It's possible that when you do an addition, there would be some, because in the addition you may get some, say C1. So now you are adding C1 WWU, and there will be some C2 coming here, and then by this you get something C3. So you see that the C3 is equal to F. C3 is equal to F because they are same. There is no way that the C3 should be same because so you see these things that O plus is equal to R plus 10 times C10 C1. So let's assume C1 C10 is C2, C1000 is because 1000 place. It is better to present in this way. The C10 plus W is equal to U plus 10 multiplied by U 10 multiplied by C100. Similarly, C100 and add it to the T plus T. It is O plus 10 into C1000. So and C1000 is equal to F. So this is what the constants are, and we want to find out the solution for this thing. Okay, I leave it to, but I think this is not difficult. In the next class, maybe we can discuss that what is the right solution and the way to tell that all these things should be different. R0C should be different, and this is WUC. And there should be similarity between something. So you can find out. I think, and this actually graphs try to build something. Initially, it gives you just an idea that from this equation you can find out the things you need to specify, and also you need to find out all difference. How to find the solution? We will discuss further into the next classes. So I think that's all for today. So next class we'll be seeing that how we can go ahead and find out the solution. given these things. The way you can, I can give you a pointer that you can see that what is the integer programming. Find out, see that what is the linear programming, what is the integer programming. Try to see that what are the solution. We're discussing in the next class. That's all for today. So I suggest you that you go and read the chapter 5 and 6. Both the chapters are covered, not completely, but portion of the chapter 6 has been started. So hope you can find it useful. I suggest you that chapter 5 you can read by yourself. The complete story, it looks like a novel. You just read that. It's very easy because you see that all the things that I told you, that you may have your own intuition also. Sometimes you'll be seeing the first time, therefore they are giving some information to you, but most of the time it's an idea to read those things. Now, students are asking about the question. Please save. Any questions? So close this session right now, and if you have a question, you can ask it and keep going on. Okay.